Okay, so I think I am finally live how I wanted it to be, and I would not use music now because I do not know, it has some problems. Anyways, so mhm, what is this stream settings and stream health? It's fine. It seems good. Okay, so what is the plan? Plan is simply working on this positionless Swift thing, and I would try to do some API design thinking, right? And we'll try to add comments on the PR based on that, so that we can carry forward the discussion at least in the next Hilo meeting. So uh, we have the simple goal. I am excited to know if there is anything in the Hilo Slack. Doesn't appear to be there. Nice. Got it. So let me open GIMP and let me give a thinking here. Hmm. I also want the pencil color to be black, but I don't know how to make it black. There should be brush, and there should be some way to say it. Colors like, wow, it's so hard to do these things like pencil normal, all of it is there, but I don't know how to make the color thing. Okay, here it is, and I want it to be fully black. Yeah, so here is my thinking, right? I have an array, and that I treat as a collection. Now for that array we can actually project something, right? So let's say these are the partitioning, and these partitioning are basically, so this is a kind of partitioning we have, and a partitioning is array of slices, and a slice is a subsequence, right? So that is the whole idea of this collection model. Now coming to the API design, let me go to collection.swift, right? So we can project different kind of things from collection, right? So what I can do is I can project parts, and I can project slice. Now this parts and slice thing is the projection of partitioning and slices, right? Slice, I have concern over the mutability thing, because if you see this callback function f, I pass the slice as an inout, and why I pass it as an inout is I can drop some elements from the front of the slice, and I can drop some elements from the back of the slice, right? But that should not affect uh, that should not affect the that should not affect the actual collection. The actual collection should be unchanged because this protocol collection does not support any mutation at all. So that was the idea. Now, for that, I believe, let's say I have let ARR is something 1, 2, 3, and I do like ARR dot with slice and some function f, okay, with slice f. So this function should not have f should not have any access to mutate the base collection. What does that mean is f would receive a slice and the slice should not have a way to mutate the base collection, right? A slice should not have a way to mutate the base collection. And this suggests how does slice get a way to mutate the base collection? Usually by some kind of handle, right? Now I believe that handle itself should not be mutable. So this is my hypothesis. My hypothesis is basically I have a slice and that slice should not have access to mutate the base collection, right? And how does slice get a way to mutate the base collection? Using some sort of handle to the base collection, and that handle to the base collection should not be mutable. What does that actually lead to according to me is there are two kind of slices. One, immutable slice. Second, mutable slice. Why I'm saying this is immutable slice would have immutable handle to the base collection, and mutable slice would have mutable handle to the base collection. So this is my idea, overall idea. Now I have to consider the possibility where mutable slice can, so I need to consider if we can unify mutable slice and immutable slice, right? I believe this is not possible, uh, but let me think about it. So, how do I think about it? Hmm. So, I start with assumption that type system does not provide any way to mutate an immutable thing. Wow. So let's start with an example of vector. Let's start with an example of stud vector. For implementing vector, it's like vector and base and mem pointer, right? And this mem pointer does not have any memory pointer, right? Or pointer to memory, right? Now this pointer does not have any concept of mutable or immutability. Like this is mutable by default, so this is mutable by default. So the base members are mutable by default. Hmm. Now if slices are implementation detail of vector, slices can contain pointer. Hmm. Now, if slices contain pointer, then any change through slices, any change to memory using slices would not be visible, right? Now, if I project a slice, a vector slice, then that vector slice could just contain pointer to the memory, and that would be good enough. Hmm, that would be good enough. I don't know if it is all making sense. So basically, slice would be like simply pointer to memory and bounds. So this is how slice would look like, right? Now, here the case, okay, the case I'm thinking right now is I have a slice and I can change elements through that, but even a non-mutating function in the vector can do that, right? Because it has a something like unsafe like a pointer, it's a mutable pointer in there, and a non-mutating function can also do that. Or it should not be able to do that. So if I have a pointer, then there are two kinds of operation we can do. Okay, so if we have semantics like this, a pointer is sim pointer does not have classification of mutable, yeah, immutable, and any mutation that need to go through pointer should go through some mutable API, and any and other things can go through immutable API. What do we think about this one? So pointer does not have classification of mutable and immutable. Pointer is like just a pointer, and now if you want to change, you have to do all these things like mutable and immutable wala thing. And this thing looks nice. This thing looks nice. Should go through some mutable API, and other things can go through immutable API. This thing looks so nice. So now I want to check with ChatGPT, because I am bad at Swift, that do we have in Swift the concept of mutable pointer and immutable pointer, or do we have uh, this API design principle that any changes through pointer should go through some non-mediating function? So if that would be the case, that would be good, right? In Swift, do we have concept of string pointer and non-pointer, or do we have, yes, sure, that there is only one kind of pointer, that pointer towards two APIs, one requires non-mediating function and other requires mediating function for mediation. In Swift model, the second one, there is only one kind of pointer, but how you can use it depends on mutability of the context. So mutating versus non-mutating is a property of pointers themselves, but the method is not a property of pointer themselves, but method on value types, struct or enums. A mutating means this method may change self, and therefore requires that self is stored in a mutable binding, right? uh so here is my problem, like I do not think a type system can ensure this thing. Why I'm saying that is I get a pointer to something, and now if that pointer is mutable, okay, so here's my example of contradiction. So let AR is something, and I'm just writing fake Swift, and I do like where E is array, right? So I have pointed to E, and that way I should be able to change ARR, but that should not be the case. So I should not be able to get a pointer to ARR at all. So this should not be allowed. This should not be allowed, right? because then I can do something like star e equal to something else, and that should not be the case, right? Or we can be like, okay, once you get into the pointer semantics, all of this is gone, and now like the type system does not guarantee anything, and we can escape from all this complexity. If that would be the case, then it would be really easy, right? So let's see. Swift has types like unsafe pointer, unsafe memory mutable pointer, and unsafe buffer pointer or unsafe mutable buffer pointer. Here, Swift does distinguish two kinds of pointers at type level. Unsafe pointer allows read access. Unsafe mutable pointer allows both read and write access. So pointer themselves do not encode mutability at type level. Do encode mutability at type level. Wow. Hmm. Here you can read independent keyword for raw memory value type. There is only one pointer to self. Swift has for raw memory. Swift has this. So I need example to this one. Like I need example to this one as code. Okay, got it. Here some simple example. Uh, this counter c1 dot increment, c2 dot increment, c2 dot double. Let's let. No, in this one pointer was not involved. Ah, I see you are asking your accessor pointer self. Okay, box. I do not like box. Fine. Right. So I believe there are two kinds. So I can conclude there are two kind of pointers. One which does allow mutation, two which doesn't allow mutation in Swift, right? Yes, you can think of it exactly that way in Swift. There are two effective kind of pointer to self: language, non-mutating pointer, and mutating pointer. Okay. But Swift does not express to self language like answer. That language like answer. So it does meta declaration, and that is fine because I need to work at this level. I need to work at this level. I need a way so that I can decouple myself from mutability. So that is the goal. Hmm. In the array implementation, I see it returns pointer. I think I would pause for some minutes. Okay, I am back, and I think this is just a bad way of streaming for sure. Oh, wow. Hmm. I don't know if I want to continue further because there is a big gap now, right? So I basically do not want to continue further, to be honest. Uh, but let's see how it goes. If I get some notification or something, I would now consider to make this stream private and yeah, proceed like that. Anyway, so here is my idea. This is something that should not be allowed by type system. That is what I'm thinking. If this is allowed by type system, then yeah, all the problem of mutation is just solved because there is a way around you can mutate a immutable variable in the language by going unsafe. But because this is unsafe, should it be allowed? I believe that should be answered, right? Uh, because in the C++ world, I do not think it's allowed, right? Okay. Hmm. So, and here I am also seeing there is a way I can get away with this. The only thing I see is even if I want to change something, it should not be allowed by default. It's just that the representation should be there, right? So there should not be a way to project a pointer out of it, like a pointer out of a projection, a collection. So that is my uh, thing. But when it comes to internal implementation, it might be possible that we have a pointer to the original collection. So there is a way, right? There is a way. So because this slice example, in this slice example, because slice can be an implementation detail of the vector, and thus slice can actually contain this pointer, but there should not be a way to get this pointer out of the vector, right? Or mutable reference to this immutable vector, or mutable pointer to this immutable vector, whatever it is. So that is my point. Hmm, how's that? Uh, but what I feel is this is the case with array. What about other collections? Can we do the same with other collections? And then there comes this thing that that slice itself I am passing as mutable, right? I am projecting this slice as mutable. So if the slice is projected as mutable, then the pointer inside is mutable, and that is a problem for me. So if I know that the collection, okay, here comes my reasoning. So let's say we have unified slice. So current situation Swift, we can, oh, okay, okay, we can project a slice. So we can project a slice out of collection. However, if that's a lit collection, then the projected slice is a lit, right? Now for our case, we want to project a slice out of collection, but that collection can be let, and still I want my slice to be in out. Now for one, if slice is let, then doesn't matter if there is some mutable pointer inside, because we cannot do any sort of mutation using that, right? So if we have mutable pointer inside, we do not care, right? Because the slice is a let, the slice is a let. And for two, if slice is in out, then if mutable pointer is present, then we can actually do mutation. And this is a thing, this is problematic, this is problematic, right? Because slice is in out, and now there is nothing that is stopping you from mutating using the mutable pointer, because type system knows about that context that slice is mutable. One idea I always have, uh, that a projection has two parts. One part is the real part, and one is additional layer, right? So a projection has basically two parts, and I want to change those additional layer things. And this additional layer thing is like bounds and other things, and I do not want to change the real part. That is the case. But can we actually encode this to a type system is a question mark. That a projection has two things, the real part and additional layer, right? So if we take slice example, then reference to base collection elements view is the real part, and additional layer is the bounds and the shape, right? So that is the additional layer, and I want to change that additional layer and not the real part. But what is this thing, the real part and the additional layer? Like, uh, is there a way to encode this in type system? The real part thing. I do not think so, or do I? So this is some kind of yeah, and then the problem would be the real part should be mutable or immutable, but then the problem would be we are not projecting one thing, we are projecting basically two things, right? The additional layer and the real part, right? Okay, how is this session like? We are basically projecting two things, the real part and the additional layer, and the additional layer is mutable, but real part is immutable. Well, I do not know about, but then it would come like, okay, at some point we would want real part to be mutable also, but that is only just adding mutability to the real part. But then it would come like, hey, can this real part be, because that, if that real part can have mutability, right, then we can expose that mutability again outward. Same problem, right? It's the same problem. Or no, it's the Swift problem. It's a Swift thing, right? It's the Swift. wala thing. Just that then it would be like Swift wala thing, and in Swift we have unified slices. So hmm hmm yes, then it would be Swift wala thing. Hmm. And let's say we have bounds and swap ends on this bounds thing. So slices has thing called bounds, and then we can do swap ends. But now again, bounds is a kind of positioning. So I do not want to decouple bounds from slices. Wow, this is complex. So, I believe we have enough reasoning that why mutable slice and immutable slice should not be there. Now, coming to the partitioning, that if we have partitioning, okay, so what is the reasoning for partitioning? Now I can just take it forward. Like if we have unified partitioning, then there should be two things: unified partitioning, then that unified partitioning can project mutable as well as immutable slices. Now to project immutable slice, it should have mutable handle to self to base collection. That means if we have mutable handle to the base collection, that means it's a problem. That means okay, so if we have mutable handle to the base collection, I am done, right? And partitioning is in out, it's a problem. It's a problem, right? And partitioning is in out, it's a problem. So yeah, this logic, to be honest, is something really great for me, and I would actually store it somewhere. E slices dot slices mutability slices dot md, and I would store it. Okay. Uh, anyways, so yeah, I can just say CPP and everything would just work. Anyways, huh? I can go to the positionless wallet thing and then I can just comment all of it. So I believe there are three kinds of. I believe there is a projectioning. So Mm, I have to write a comment. So regarding projections from a partitioning, I believe there are three kinds of projections, out of which two are implemented. First, with additional parts, first, which adds additional partitions to additional which project partitioning with additional partitions, and after example bisection to quadri section for rotate algorithm, right? Bisection to quadrisection for rotate algorithm. Uh, for rotate algorithm, this projection also this this method boundaries of projected partitioning. Uh, After callback completes current implementation with additional parts, project partitioning with additional project project partitioning with few contiguous partitions with some contiguous parts. Example would be quadri section to bisection. Say I want to rotate a bisection while working on a quadri section. Okay, so that is an example. Boundary behavior. Hmm. Okay, I think I should uh copy paste it. I think I should copy paste it and try to write it and comment.md. Okay, so current implementation is this thing, and second is partitioning with some contiguous parts, right? Regarding example, quadrisection to bisection. I want to rotate a bisection while working on a quadrisection. Bisection. I want to rotate a bisection while working on a quadrisection, and boundary behavior. Wow, boundary behavior is simply current partitioning also adopts boundaries of projected partitioning after callback completes. Current implementation uh, not implemented, right? What is the third thing? I think project current partitioning such that project current partitioning such that it does not adopt boundary of uh, projected partitioning. Quadrisection to bisection. Example, uh, rotate quadrisection needed the same. Okay, rotate quadrisection needed the same. Mm, boundary behavior current partitioning does not dot boundary after callback completes. Current implementation with projection. right? Now, coming to having idea of mutable slices and immutable slices, idea of distinction of mutable slices and immutable slices. Having idea of having distinction of mutable slices and immutable slices. Um, if we are distinguishing between mid if we are going to have two kind of slices, I believe we should also have two kind of partitioning too, as partitioning only projects the slices, or partitioning is nothing but uh, abutting slices, right? Is nothing but abutting slices. Hmm. Nothing but disjoint contiguous slices. And partitioning can only have same partitioning cannot project mutable and immutable slices, as for projecting mutable slices it should have mutable handle to base collection, have some kind of mutable handle to base collection. So now coming to having distinction of mutable slices and immutable slices, if we are going to have two kind of slices, two kind two different kind of slices, I believe we should also have two different kind of partitioning too, as partitioning is nothing but disjoint contiguous slices. Same partitioning, unified partitioning cannot project mutable and immutable slices, as handle this as for projecting mutable should have some kind of mutable handle to base collection, and that should not be possible for let collections. So considering this case, let's say we have mutable parts mute associated type in mutable collection protocol. I would then parse mute should effectively follows mutable partitioning protocol should have 6 projection methods. Three above described. This includes the three described above and 6 partitioning projection methods, right? This includes 3 described above and 3 more that are respective mutable partition pro that are 3 respective mutable partitioning functions of the same. Also access part I should be the methods part I part mute I. What is the problem? Okay, part mute I. returns immutable projects immutable ith immutable slice projects ith immutable slice. Hmm. Oh no. If we able to use subscript operator for the same thing. Use subscript operators for the same. Oh, Hilo can solve the maybe Hilo can solve the problem uh, with some syntax you were discussing, not aware of. So regarding projections of partitioning, I believe there are three kind of projections, out of which uh, I have few. I have few. Complete the there's some points I think we need to discuss to complete. These I have some points. We need to discuss to complete the collection. Uh, this we are exploring regarding projections from partitioning. From given partitioning, I believe there are three kind of projections. There are three kind of projection, out of which two are implemented. Project partitioning with additional parts, bisection to partition for rotate algorithm, boundary behavior. Current partitioning also adapts boundary of project partitioning after callback completes. Current with additional parts. project partitioning with some contis uh, with few contiguous parts. Example, quadrisection to bisection. I want to rotate a bisection of current partition while on a quadrisection. Boundary behavior. Current partitioning also adopts boundaries of projected partitioning. After callback completes current condition not implemented. Project partition of all parts, but after callback complete, it does not adopt boundary of project. But after callback complete, does not adopt boundary of projected partitioning. Root quadrisection needed at the same boundary with current partition does not adopt boundaries of projected partition. Where the current partition does not adopt boundaries of projected partition after callback completes with projection. Now coming to having distinction of midwell. Do you mm, think there are any other kind of partitioning projections I am missing here, or there is some redundancy? That is the first thing. Second thing is now coming to having distinction of midwell slices and immutable slices. If you are going to have two different kind of slices, I believe we should also have two different kind of partitioning too, as partitioning is nothing but disjoint contiguous slices. Unified partitioning cannot handle this, as for projecting mutable slices, it should have some kind of mutable handle to base collection, and that should not be possible for lit collections. So considering this case, let's say we have parts mute as a type in mutable collection protocol, then parts mute should then part mute that part okay. Six partition operation method. This includes three described above and three more that also to access parts I slice. There should be two kinds of methods. Subscript part I script part mute I to Plus, percent mute. Do you think we are aligned on this? Do you think we are aligned on this? Or there is something? Or do you think we are? Okay, nice. I think I have written all the comments I wanted to. Yeah, this is that was all I had. So Dave, I have some points I think we need to discuss to concretize the collection idea this PR is exploring regarding projected partitioning and this. I think I should do some changes in this one. So yeah, these things were fine, but not at the same time. I think this is something, yeah, I should comment because this was an important thing, right? Uh, Dave Abraham's all this idea was very important to discuss. I don't know. This stream did not get the traction, to be honest. But there was so much I was doing, and I don't know if I want this stream to get the traction at all, to be really honest. So I'll prioritize this stream too. Anyways, yeah, that was all I had, and now I'll be waiting for the Dave Abraham's reply. And see you guys soon. Jai Shri Ram.